So the challenge always with giving talks like this to an audience like you is some degree of soul searching about whether I can make relatively simple statements that are, hopefully either currently or historically, interesting or accurate, and at least, cause some degree of thinking, on your part. Um, for here today, I wanted to talk about, um, a bit of my own experience in the space, and largely a lexicon, that I use, meaning specific vocabulary that looks at long-term technology trends in both, edge and cloud and networks. Talk a bit about the lessons from the emergence of clouds and what that means, a way to think about edge, and then a pretty simple statement about openness and the evolution of the networks. I mean, to me, the way the networks are moving is, perhaps obvious to subtle. We'll see. So the lexicon for me is just a long, just a way to think long term about applications and infrastructure changes, and it has a bit of a difference, from the usual sort of technology terms in there. For me, it's five nouns, three verbs. They're meant to be things that I notice that are different, but come up quite often. The first one is interplay as a term that I use, and for here, it's about the continuous interplay between hardware and software needs, and we're going to anchor a little bit of at least the history of clouds in a conversation about interplaying, in that, because whether we realize it or not, a lot of the component market, what goes on there, supply chains, hardware capabilities, the transition in the 64-bit systems, the elimination of specialized compute, the going along, certain SoC designs, the rise of quantum computing, all these types of hardware changes, in fact, drive quite a bit of, what's going to occur in the software space and basically what's possible. And we'll talk a little bit about how, from that perspective, a lot of things happen in cloud computing and the networking space that becomes pretty obvious when you think of it from sort of a hardware perspective, that's in there. People only see part of my slides. Yeah, I don't know. What I can do to fix that. And then we have a continuous, distributed, data-centric tenancy, instrument, optimize. We'll touch upon these just a little bit, in there. But when we look at things around cloud, edge computing, the way that networks are actually being broken up, these are all of the words that I commonly use for what sort of occurs. You'll see continuous and continuously improving and continuously this and continuously that and continuously optimizing showing up sort of quite a bit. These are now distributed systems, and they weren't distributed systems before. Everything's very much a data-centric type design, and that was not the case before. The rise of cloud and edge and even current network designs are all meant to be multi-tenant in there. And there's something subtle in the sense of how these are instrumented, in that we have more metadata about what's going on than ever. And that leads to certain things from both an optimization and an automation standpoint, that are fundamentally changing. Not just the application designs, but from an operational standpoint, what the total thing that's in there. Now, a quick question that came up in real time here, which I can address, is, clouds emerging compared with mainframe computing 3 decades ago. Is history repeating itself from centralized to decentralized to distributed? And that's a very good question. And what I would say is that the big insight there is that centralized and decentralized are both types of distributed systems. And so when you think of a good distributed system, if you apply a policy to that, it can be decentralized. If you apply a policy to that, it can be centralized. And so generally, distributed systems are the difficult thing to do. You can go and make trade-offs and decisions to make it more decentralized or centralized. And so when you decide to do something that's centralized or decentralized, you're making trade-offs, or the need's not that large, sort of like in there. But if you sit down and you think, how do we do distributed systems well? That type of thinking always basically applies to there. And I think that's why, I put it there in that spot. So part of this, like just to give you a quick example, the interplay part of it is the big bang for cloud computing was this interplay of 64-bit x86 and Web 2.0 style architectures, and not just like the website part of it. And so what I mean is, like, prior to 2003, as an example, virtualization was dominated by these types of operating system level virtualizations and hardware level virtualization. They were called these two things, and they went by different names. I mean, LPAR, for example, is a mainframe term. It's that type of logical partitions that are on mainframes, and you do that sort of, quote unquote, virtualization that was there. LDOMs was a Spark concept, jails on BSD, zones on Solaris, containers on both Solaris and then sort of like Linux, and so on like that. And this type of virtualization, while it allowed for multi-tenancy, it didn't allow for any type of chipset or operating system heterogeneity, that's sort of like in there. And then you actually really had operating system heterogeneity show up on x86. That was only done by two methods in the space, and that was really binary translation and paravirtualization, both in VMware and Xen, from those technology standpoints. But of course, those had a performance cost to them. But really in April 2003, the thing that kicked all this off was AMD launching a 64-bit x86 chip. Intel's strategy for 64-bit was to go Itanium. There was still sort of chip wars going on in that sort of period of time. And the sort of 64-bit memory space meant that multi-tenancy was even possible. Up until then, the largest server you could build was, in the sort of x86 was a 4 gig of RAM, server, in that. And if you headed off to the other platforms, were already 64-bit, you were heading into quote unquote big iron, just sort of, almost like mainframes for web apps type sort of things, like some of the big Sunboxes and the like. And then what we saw is x86 really become the dominant data center chip platform, from literally 2003 all the way up to 2013, in that. And what you started seeing was specific features in chip releases that would offload capabilities of virtualization, that would offload memory, and so on like that. And this is really what basically kicked it off. And then a lot of the Web 2.0 applications, were, interactive, mobile, social, and monetized. But what happened really was the back office exploded, for these applications. And you had not just a tremendous amount of data, but a tremendous amount of metadata. And so all the things about how people interact with each other on Twitter is a significantly larger data set than Twitter itself, from what you go and sort of basically read. And I think, as we'll see here towards the end, the insight on this is that networks begin to suffer from the same thing, as we sort of go and see that. Now, in the networking domains, what happened in the last 6 years was the merchant silicon and chip providers started providing hardware offload for networking, whether it be things like Skylake from Intel, FPGA offloads on the specific NIC designs, and so on like that. And the consequence was really that a lot of the multi-tenancy concepts and different virtualization concepts could show up in both the data plane and the control plane of networks, by, say, really 2016, 2017. And we started really getting rid of this distinction that somehow, even things like RAN was a special workload, from that perspective, when they started taking, more of those types of, designs. We continue to sort of go and move into that type of, programmability. And so, the big lesson in both the cloud space, if you will, was that all applications have, of course, data that they consume that sort of sits in this data path, but they also have a lot of metadata that gets increasingly generated, sort of in that. All of this is what drives things around optimization and care. It becomes the basis of how one automates. And so this type of idea that you have machine learning show up to improve the functionality, scale, and performance of applications, that starts feeding into concepts like a RAN intelligent controller and different sort of operational systems that, appear in the network. And really the sort of idea that an optimization process and a care process that has certain machine learning technologies in it is what ends up driving automation and the intent and the behavior of that, and really almost the control of it, becomes, really sort of important. So you have this explosion of a lot of practical activities and optimization, largely because it's computationally possible. It begins to sort of touch many aspects of the system. But I think the subtlety there is then a lot of the control planes and operational systems that you start putting around these data paths become a certain architectural style of application. It becomes dominated by the data collection and the machine learning aspect of it. Just like, again, if you look at the sort of total infrastructure of even a large web property, a big part of it is the behavioral data, the social data, the metadata of interactions, and sort of everything else, and what's being done with advertising. In a lot of ways, I think the thing to keep in mind around networks is we have an explosion of metadata, about what's going on in the network as well. Now, I just want to touch upon, that sort of relatively simple lexicon, that always works. I just want to tell you at least what I think clouds are, and then I'll tell you what I think edges are, and we'll come to some relatively simple conclusions in our last sort of period of time in there. But so far what we've headed into is applications use and generate data, but there's all this metadata around it. The metadata is used for the control of that, and it's really sort of dealing with the explosion of there that makes using clouds interesting. Now, cloud in the last, again, I think April 2003, that's the big bang of cloud. It's the sort of availability of 64-bit x86. So we're sort of 18, 19 years into that. And I guess it'll be 19 years this upcoming month. Cloud became a highly accessible industrialized infrastructure. That's a definition that I proposed 18 years ago, and it's basically stuck in that. And then what we saw infrastructure emerge as this practice of its own, not just something that's subservient to the applications, but this idea that you could have an infrastructure practice within your company, and so on. Being highly accessible, which to me is a lot more precise of a term than open, in there, has consequences to all the non-functional aspects of these types of systems and these types of products. So just the decision to make something highly accessible and programmable, and the other sort of elements that cascade down from that, changes tenancy models, utilization, predictability. It really impacts security in it, how you maintain the software, what's possible from a maintenance window perspective, and everything else. And then being industrialized is exactly that type of supply chain thinking. So clouds that work well are clouds that can be continuously improved in there. And in fact, when you take this idea, and I didn't draw the X and Y axes here, but you can sort of sit down and say, well, one of them's increasing capabilities, another one's sort of cost, in there. Anytime you can sort of exponentially increase capabilities but keep cost flat, anytime you can sort of keep capabilities about but exponentially take cost out because of the way that you've introduced new infrastructure practices, anytime that you can sort of do both of those along that curve and be out, or start having a bit more of this continuously improving supply chain type thinking show up. That is the definition of hyperscale. And so hyperscale approaches are ones where you are able to continuously improve capabilities and cost. And you actually take them from linear to exponential as often as you can, or, at least this sort of S type function goes up, exponential stays flat, goes up, depending on sort of the way it basically looks. But that's what hyperscale and hyperscalers basically means from the fundamental standpoint is all that supply chain thinking showing up. And again, this is just, the type of things we're changing accessibility. There are ISO specifications of non-functional aspects of software systems. And, you can sort of go through and things you'd normally check off in a big export list, they all get basically impacted, from that. And I think, and that's where what we really saw, over a period of time was really that type of change in the space that, clouds and that whole sort of practice ended up changing quite a bit what people were doing. Now, the fundamentals for me then, as it says, is if we sort of go into edge is not, terribly sort of different in thinking, from cloud. I think there is a long-term defensible definition of edge. It tends to be the infrastructure that's embedded within networks, and that's not just, it's basically, anything in there. That's one common way of thinking about it. I think there's a more general, way of thinking about edges. But there's a lot of this talk now of having this industry abstraction be a device talking to an edge, talking to a cloud. And the different types of networks have these types of embedded application environments and so on like that. I think that when we head into a much simpler concept of edge, in particular, its relationship to clouds, is edges are hyperlocal. The simplest way of thinking about it is the hyperscale clouds have this type of highly accessible multi-tenant industrialized infrastructure. They sort of go and do that. As we said at the bottom there, the hardest things around converting to being cloud native, in my opinion, really is how people start handling the metadata about everything that they're doing. Typically sort of that type of distributed system thinking, and then usually sort of like handling, multi-tenancy. Edge to me is simply location specific cloud computing. So something's not just off in the clouds, but it's actually got this hyperlocal element to it. And so there ends up being quite a bit around, native location services and different metadata capabilities that sort of show up around that, the like. But edge fundamentally uses and extends all these concepts out of cloud, but we really just think of it as location specific cloud computing. And so in a lot of ways, the public clouds are really sort of hyperscale, and these edges are hyperlocal. It may very well be that somebody like Amazon, Microsoft, Google both own hyperscale clouds as well as deploy hyperlocal edges, sort of in there. But the hyperscale versus hyperlocal, the idea that edge computing is really location specific cloud computing, I think will stick as a good long-term definition. It's about as simple as we can sort of go and get. And then, as we said before, it's a lot of these changes in application patterns that have at least been driving the need for this type of location specific cloud computing, sort of in there. It's as simple as not just, basically data sending out, but it's really around the sort of bidirectional sort of data flows, in there. And I think being edge native just simply means that you have this location specific and topology specific cloud computing need. There's always a device. There's increasingly people talking about, edge native applications, and edge native application services, infrastructure, the infrastructure itself, cloud native application services, infrastructure, cloud native, and so on. And as you basically go from one end of the infrastructure to the other, it tends to go from relatively dynamic, distributed, mobile, location specific, and declarative type designs to things that are more static, centralized, immobile. You don't really necessarily care, where something is, and it's imperative. But increasingly, this type of structure, applies okay. Now, I think the two core types of applications that show up in there is, the network itself, and then flow apps. And, a good way to think about it is just like content delivery, but now the content is going in both directions. And you're actually trying to do different types of computational events along that stream of data. The flow applications and these types of pipeline designs, I think, are a much more important architectural shift than many of us realize. In that this is where computer vision, machine learning, AI, different optimization techniques show up in this style of architectures. And even a lot of the control elements of the network are now of this type of design, sort of like in there. These two are not necessarily dependent on any sort of like device hardware showing up. The other sort of two future use cases you see quite a bit out there is really metaverse use cases, but that's going to depend on glasses and headsets and other sort of capabilities, in that. So it's going to take some period of time to show up. And then, basically autonomous control systems, in there. And so, the conclusions aren't super groundbreaking, from that perspective. But I think if you walk around and just say, look, clouds are highly accessible infrastructure and services. Edge, the best we're going to come to right now is it's location specific cloud computing. And there's a number of sort of element and services in that. Hyperlocal and hyperscale are the two terms that basically become in use, that become in common use. The drivers for this are always changes in application architectures, but it's also really the explosion of metadata around the network elements themselves, and really the increasing commonality of all the machine learning and AI capabilities. So the fact that you start having machine learning driven control systems, sort of in that. And I think the networks themselves are all subject to exactly the same type of broader industry trends. It's not just sort of some standalone element that goes off on its own anymore, but all this increase in metadata, the transition to intelligent control systems that are that flow application design is exactly what makes more and more of these elements of the network have high accessibility requirements, as well as make them appear to be edge native, and cloud native type sort of elements. And what makes it sort of naturally amenable for running on this. And with that, I'm done.
Thank you, Jason. I've got a couple of questions for you. You said about the edge is always going to link back into the cloud. Is that true? Because a previous speaker at one of our events from BT, John Davis, Professor John Davis, gave an example of checking traffic. And all the images were discarded because that's what they were looking for. They were counting cars, well, counting vehicles. So, I mean, not always surely will the edge be linked back into the cloud?
No, but the sort of like default optionality that most people expect is to have a full set of capabilities. I mean, if you stop, because part of it today is people can do things on a device and they can do things on a cloud. And in fact, the infrastructure that's in between doesn't have a lot of capabilities. And so if we're adding edge services in there, we're adding additional capabilities. People may use those capabilities that are there and just use them, or they're going to use them in coordination with other things. The only time you're going to see them use just the edge is when it's a brand new use case.
Okay.
Yeah,
we've got a couple of questions for you. One is from Dean Bobby, who says a lot of location-specific functions are quite latency tolerant. A water level tank may only need to be monitored once an hour, or a room temperature once a minute. Do they need edge? Talking about use cases.
Well, so the thing is, and it was a little buried in the slide, but all of the edge use cases, they do tend to be bandwidth intensive, not latency, sort of like sensitive in it. I think as Dean says, some of them are sort of not. I guess the other way of framing the question is, does that particular application have a need for location specificity? Location specificity may translate into performance requirements. It may translate into cost. It may translate into things around data sovereignty, privacy, regulatory reasons. It could be alike, but I think what you'll see is that all of the stuff that's going on right now, do those things absolutely need edge? No, because they don't use them today. The sort of question is almost, are there applications that will be emerging and devices that will be emerging that do need it? Or there are things that are not really optimized or done well today that, if an edge existed, they could sort of go and do that. But I think it's, the specific examples Dean mentioned there, those don't necessarily use edge today. They don't necessarily need it, per se. Unless again, there's some type of regulatory requirement for that location specificity.
Okay, thank you. And we have a question from Leon. He says, great presentation. And where would you put Web3 in this vision of yours?
Yeah, it's a very good question. Web 3.0 is, and these are, sort of the application of blockchain and these types of things. I would put that in my way of thinking is that is a distributed system and those technologies are all about basically guaranteeing the integrity and chain of custody of metadata. I mean, if you really look at like what 3.0 is, Web 3.0 is about actually having a series of different technologies in place, blockchain and the like, that's in there. But that is about really the guaranteed integrity and sharing of metadata information. And so, it definitely fits.
Okay, and Jason, I wonder if you've got any views on how Edge could be applied to Open RAN?
I think Open RAN, as we said, is like the Open RAN is an Edge workload. Like period. And particularly when you sort of look at all the things around the control of it, the desire for that to actually be a metadata driven and machine learning optimized, non-human intervened control system means that, the whole Open RAN controller and everything else that's there and the thinking about it is inherently an application of that type of flow and pipeline style design. It has to run in specific locations. So, I mean, that by definition, at least for me, in a rather circular way, makes it an edge workload. Okay,
it's interesting because among some operators, there's still debate about that. So it's interesting that for you, it's much more clear cut. For example, I know Philippe Esargay, who's our final keynote today, is a bit less concrete. He thinks it will happen eventually, but there's some buts.
Yeah, and the buts are not technical. The buts tend to be around just the buts are other reasons. So, but as we said, like even in the beginning of Anna Karina, I mean, all happy families are the same, and all unhappy families are unhappy in their own way. So, there's each operator is going to have their own story about their network.
I didn't realize they were all tragic. Anyway, we have another question here. In your opinion, are mobile network operators ready to share (brackets) outsource their 5G network functions on public cloud, or is Edge good enough as a private cloud? Sorry for my mess of the question.
Yeah, no, you didn't. Yeah, it goes back to it really depends on the operator. I think operators will make their decisions based on financial constraints, sort of, if you will, and the current procurement regime and so on like that. And so I think the certain evolution of a given operator, if there's really a superior operational story, financial story, better customer outcome and retention and that type of things, then these sort of technologies become relatively easy to argue for. If those things are not there, then it just basically has to be championed by, whoever's going to be craziest, inside of that organization, in that. And to home in on the last part of that question, edge will be the new word for an operator, private cloud. Yeah, that's true. So we'll just call them edges now, but it's just private cloud. I don't know, give it a version number, if you will, 3.0, something like that.
When do you think we're going to get over looking at edge in this particular way and look at it as part of the whole?
Well, I think we have, I mean, you can almost sit there and say that the question is, I try to anchor the definition of edge in a broader conversation about cloud and really a transformation that started 19 years ago. I mean, I think when we look at, the idea that we have highly accessible infrastructure that is as its own practice and it's horizontalized and there's inputs into it that are really sort of largely not, they're not trying to think of the whole thing as some big integrated stack that has to move along together, but you can innovate on this layer as rapidly as you can, and make relatively sort of brutal supply chain choices and the like. That people are still in the middle of understanding what quote unquote cloud is. And so, I try to not make the edge story more complex, in the sense of like, well, look, you still have to actually understand what cloud computing is, but your stuff's just off in the cloud. The second you say, well, I have to know where my things are, there's some location specificity or some location requirement to my cloud computing needs for a wide variety of, again, performance to regulatory reasons and, maybe financial, and the like. My suggestion to people is go understand what cloud computing is, and then understand that location specific cloud computing is edge. And then understand that operators by definition need to know where all their stuff is. An operator can have a cloud strategy, an edge strategy, and a SaaS strategy, and have a pretty comprehensive technology strategy, just by covering those sort of big three categories.
Okay, Dario, I see you've asked a question, but I think Jason's kind of addressed it. So really quickly, Stead Japan has asked, what are the directions and best options for ensuring interoperability across the board and hybrid cloud orchestration that would include edge, public, private, and all the rest of it? I don't know if you can answer that quickly, but it seems like a good question.
Yeah, I mean, a lot of the interoperability, the best thing there is that most of these do have relatively common interfaces, and almost all the interfaces tend to be RESTful based, and they do have common data formats that are JSON based and so on like that. And so, you're essentially, when you need to do hybrid cloud, or you need to do multi-cloud things, or you need to orchestrate across it, then generally the body of software you're writing inside of your company is almost like the equivalent of a language translator, or a compiler of some type, where you're basically taking one JSON payload and converting it to another JSON payload and then running, the sort of quality against it. And so it's basically the nature of the software and the automation that you're doing shifts a little bit in those types of environments. But the practice is a little bit like, how do you turn a Java application into a C application and vice versa, and cross compile, and you start thinking in those sorts of ways.
Jason, thank you very much. We're out of time. That was very thought-provoking, deceptively simple thinking, I would say.
I'm a very simple person, yeah.
Anyway, I hope you have a good night's sleep.
I'm like all coffeeed up. Yeah, we'll never know.
All right then. Thank you very much indeed.